Hey guys, this is going to be a really quick video going over the basics of dilations and then talking about how to find the scale factor as well as the center of dilation. Now, from class, you should have learned that a dilation is a type of transformation. It is a non-rigid transformation, which means that the shape is going to change sizes. So essentially a dilation is when you have the same shape, but it has changed size to be either larger or smaller. Now, because of that, we can categorize dilations into two types, one being an enlargement and the other being a reduction. There we go. All right. Now, a scale factor, and we talked about this in class 2, we represent that with the letter K. And the scale factor represents how many times bigger or how many times smaller my shape is getting. So basically, if my scale factor is 3, it means that my image is going to be 3 times the size of my pre-image. If my scale factor is a half, that means that my image will be a half the size of my pre-image. For that reason, okay, whenever K is greater than 1, we are going to have an enlargement. Right? If I'm getting 2 times bigger, 3 times, 4 times, 5 times the size, those are all enlargements. I'm getting bigger every time. On the other hand, a reduction would be if K is smaller than 1, right? So if I said, oh, this shape is half the size or a quarter of the size or 2/5 the size, that would be smaller. So it would be a reduction. So K is going to be less than 1 for a reduction. All right. Technically, for a reduction, we are really looking at K being between 0 and 1 because a negative scale factor would be something completely different, and we're not actually going to learn about those this year. But just so you know, you're looking at a positive number that's less than 1 for a reduction. Now, what if K was equal to 1? Well, if K was equal to 1, then the shape would not be changed, so the pre-image and the image would be congruent to each other. Now we're going to look at this example on this page and figure out how do we find the scale factor. So the scale factor tells me how much bigger or smaller the image is compared to the pre-image, right? So it's basically a ratio of the size of the image to the pre-image. And a ratio, in other words, is a division. So basically what you need to do is figure out, in essence, the size of the image and the size of the pre-image. Now, we're not going to find the size of the whole image. It's not like we're looking at an area or anything, but what I am going to look is at the lengths of the sides. Specifically, you need to pick at least one corresponding side on each of the shapes. So here, I'm going to look, I think it would be easiest on my pre-image right here. You can see side AB, that is 4 units long. Okay, and on my image here, A prime, B prime, that is going to be a corresponding side, and it is 2 units. Okay, the really important thing to consider here is to remember what is your pre-image versus what's your image. Your image, right, that's what you end up with, is always going to have these primes. So A prime, B prime, C prime, that is your new shape, right? That is your image that has been transformed. So your image is always going to be what you're dividing by the pre-image. So since the length of this side on the image is 2, and the length of the side on the pre-image is 4, my scale factor is 2/4, or in other words, I can simplify this and say my scale factor, which we represent with K, is equal to 1/2. Now, thinking about this in context, it makes sense. I told you that if the scale factor is less than 1, you have a reduction. And if you look at this, because our pre-image is that purple triangle, that larger triangle, right, we then reduced to the size of our image, the blue smaller triangle. And again, you can tell which direction I'm moving because the pre-image is just plain letters A, B, and C. All right, now what about the center of dilation? The center of dilation is basically just where is this dilation occurring from. So not only is your image going to be twice, or sorry, like some number, let's say K is 2 actually. I'm going to use that as an example. Let's say K is 2 because, or let's say K is 1/2 because that's the case on this picture. K is 1/2. Not only is your image going to be half the size of the pre-image, but each point on the image is also going to be half the distance from the center. So it's going to be closer to this point we call the center of dilation. Now, to find the center of dilation, what you're going to do is you are going to draw lines basically connecting all of the vertices on the two shapes, right? So I'm going to draw a straight line connecting A and A prime. But I'm going to extend that line out because what you need to do is not just connect all the corresponding points, you also need to extend it because you want to see where those three lines, or however many it is, wherever they would cross. And the place where they all cross is your center of dilation. All right, so I'm going to extend these out. You can extend them right off the graph if you want to. So if you start and I click right here at A, I can extend that line down like so. Okay. Start here, and then I can also go from there to there. Okay. Now, ideally, I would have really extended those past that. The annotation tool I'm using right now isn't really ideal for drawing straight lines. Okay, but please know whenever you're using Pear Deck or GoFormative, which is the two platforms we're going to use for this, both of those have options for you to draw a straight line. If you're looking in GoFormative, you'll find the button. It's on the Show Your Work part. It's like right at the top left part of the screen. There's a place where it looks like you can like draw or something, and it asks you if you want to scribble or use a straight line, and you would just choose line instead of scribble. Okay? And then you can do the same thing as this. So all of those lines crossed at this point right here, that point is 0, 0. So 0, 0 is my center of dilation. In other words, I'm centered at the origin. Okay. And now I'm going to do one more example, just finding the center, because I think it's helpful to have a little bit of practice. So again, I'm going to sort of freehand draw these lines because I think it'll help you see better. But again, you should always be using a straight line tool. I just don't have a great one when I'm annotating my screen like this, but we are providing you guys with that, so you should be doing it. Basically, you're going to start on whatever the larger of the two shapes is, whether that's the pre-image or the image. Just start on a vertice of the larger shape, connect it in a straight line to the same vertice on the smaller shape, and then extend outwards. Right? And honestly, guys, that was a freehand line. I was not using a line tool, and I just did a fantastic job of making that straight. So props to me. But now I'm done bragging. We are going to continue, and I'm going to do that with the other corresponding points as well. So C and C prime. Right? I definitely bragged too soon. That was not as straight. Okay, but you get the point. It's definitely landing in the right area. And then I'm also going to be doing the same with A and A prime. Ooh. I'm like starting in the wrong place, but that's again because I'm freehanding it. Sorry. Okay, that one wasn't as perfect a line either. But again, that is what you would come up with as the intersection point if you're using straight line tools, is this point right here. Okay, in that point, I have my x value of 4 and my y value of -3. So that is at the point 4, -3. Okay. Maybe we'll find another example of scale factor just before we move on. So last example, I know I'm kind of going back to scale factor, but I just realized I only did one example. So finding the scale factor here, again, remember that the scale factor is the ratio of the size of the image to the pre-image. So I'm going to find the side length of one of the sides on the image and then one on the pre-image. Again, the image is the transformed shape. So the image is where we have these primes. The pre-image is what you started with. It's not transformed, so you have these plain old letters P, R, and Q. So this right here, this is the pre-image. I'm going to just abbreviate that to PI because there's not spaced right pre-image. Anyways, so I'm looking for the length of a side on the image. I think I'm going to pick this side right here, this lower side, RQ prime. Okay, and I can see that that is 1, 2, 3, 4, 5, 6 units long. Okay, and then I'm finding the length of the corresponding side on the other triangle, on the pre-image. So also going to be, it's this time not RQ prime, but just RQ. And that side right there looks to be 2 units long. So if I have a side on the image that is 6, corresponding with a side on the pre-image that's 2, my scale factor is 6 divided by 2, or in other words, my scale factor is 3. Okay, so hopefully this video is helpful. If you have any questions, always feel free to ask, but make sure to do your best on this Go formative, and we will go over this even more next class.